When I was in 7th grade, I wanted to create video games. I was fascinated by every single game that I played or watched, but the games that I played with my friends were the most fun. It made me really want to create a cooperative game that I could have fun playing with my friends. It's a long journey and I haven't yet created a full game that offers hours of gameplay, but I have learned a lot about game development and networking in Unreal Engine, which can help me make my dream come true. But this video is about my learning project that I made using the third-person template and some tutorials from Unreal Engine's documentation. I had 7 days to learn multiplayer and networking in Unreal Engine, and I had to do something with my knowledge that I've gained. So watch till the end to see the results. And this video will be divided into 2 parts. First part is about my learning journey, so everything that I read and watched to understand networking in Unreal Engine. Then the second part is about creating a game with a knowledge that I've gained. So let's jump into the learning chapter. And don't forget to like and subscribe if you enjoyed the video. And just a quick apology for being so quiet lately, but I was working a lot to earn some money, so I didn't really have much time. My days were pretty crazy, starting at 4 AM and finishing at 7 PM, so when I came back home I was totally worn out. But I'm back now, and hopefully I will post more often. Anyway, let's get back to the video. I learned everything that I'm about to show you from Unreal Engine's official documentation and various tutorials. However, if you're already familiar with the basics and just want to see the game creation process, you can skip to this part. I started by reading the network overview tutorial to understand the basic concepts of networking in Unreal Engine. I learned that there are 2 main systems. One is called Iris and the other is called Generic. Iris is designed for large-scale worlds with 20 or more players, so I decided to go with the generic one as I don't need Iris system, especially for learning project. Unreal Engine uses a client-server architecture, which means that there is always one host, either one player or a dedicated server, and one or more clients that connect to it. In a dedicated server game, the player joins to a separate server that is not played by a person. In a listen server game, the computer acts as both the host and the client. Because of this, all of the character movements and actions are actually calculated on host's computer, and this system is very common in cooperative games like The Forest or Peak. Next, we have a actor replication. This is a concept that I really hate, and you will see why during the game creation process. Actor replication is how Unreal Engine ensures that all players connected to the host see the same thing. So, for example, players' health should be replicated so that it's synchronized and displayed correctly on every screen. So there are 3 main mechanisms bound to replication. Replicated properties are actor variables that automatically synchronize their state across the network. Replicated using properties work the same way, but they call function when their state is changed. Finally, RPCs, known as remote procedure calls, give actors ability to call a function from one machine and execute it on other. There is more to actor replication, but I think that's enough for you to understand how Unreal Engine shares information. It's also important to know that A actors and their derived classes are the primary objects for replication. However, U objects can also replicate, but they have to be a sub-object of an actor class. Then I read something about traveling, which is just opening a new level but for a networking. While traveling is very important, I won't use it much in my learning project. I think that this is not relevant for this video. The next few chapters covered concepts that I already mentioned, but there is one concept that I haven't talked about, and it's network dormancy. Dormancy is a key optimization for a multiplayer games. It's a way to stop actor from replicating their state, which is used for actors that don't change very often. Then there was a relevancy. It is used to determine if the actor is relevant for replication. If the world is large, it is a bad practice to replicate all actors. It's better to determine if the actor is far enough so it doesn't have to replicate. And lastly, there was a chapter about execution order, which is very important because I have to know what executes first and what last. And I think that will be more for a learning chapter. I learned more things, but I think I've covered the most important ones. Let's move on to the game making chapter. I started with Unreal Engine's multiplayer programming quick start tutorial. I went step by step with this tutorial, and in a C++ third-person template, I added some variables to the character class. One of those variables was marked as replicated, and I had to explicitly tell the engine to replicate it within a specific function, so the game knew to synchronize it. The next step was to override take damage function, which is called when the apply damage function is used on the actor. The take damage function in my character class simply reduces the player's health by the incoming damage value. I needed an actor for a projectile that can cause damage to the player. I did everything the tutorial said. I added some variables and I initialized them in a constructor. Of course, the projectile movement component handles the replication itself, so the projectile could move even without explicitly replicating these variables. I did have a problem with the particle system because I used Unreal Engine 5.6, but the tutorial was written for a Unreal Engine 5.5, so the particles weren't where they supposed to be. I just downloaded some particles from Fab. Then the projectile was set up to spawn an explosion and apply damage to all the players. To make the projectile fire and spawn, I just created 3 functions in a character class. One of those functions was an RPC function. Its job was to spawn the projectile on the server so anyone can see it. And from that point, the projectile's movement component handled the rest of the replication on its own. In the next steps, everything I make is from the on your own section or just from my own creativity. The first thing that I did was expanding the onHit function from the projectile. So it generates an explosion that hits all the players that gets into that radius. However, the player who was already hit shouldn't get additional damage because it would be unfair. At first, it didn't work. The sphere trace wasn't detecting any players. After a lot of head scratching, I finally noticed the problem. I had the collision channel set to visibility instead of a pawn, so after changing that, everything worked as expected. Next, it was time to kill the player's pawn and make them respawn, because the plan is to make a prototype of the arena shooter game. Respawning itself was very easy to do, just a few lines of code and it was already working. But I wanted some more. I wanted the game to feel more immersive. So I thought RAGDOLLS would be the best way to notify the player that he actually died. And that turned out to be a big mistake. After the player died, I disabled collisions on the capsule component. I set the skeletal mesh collision profile to ragdoll and I enabled simulate physics. It worked, but only for the host, and that was extremely frustrating. I spent hours to get it to work on all machines. I even tried setting the mesh replication in the character's blueprint, and that was even bigger mistake, but you will see why in the end of this video. Finally, after a lot of time wasted, I made the enable ragdoll function a net multicast, so it runs on server and on all other clients that are connected to it. And at last, it all worked. The next step was to create a HUD to show the player's health, for now at least. That part was actually easy. I created a HUD class and a HUD widget. I added the widget to the viewport in the HUD class, and in the widget I bound the player's health percentage to the health bar. Finally, I created custom dev messages. So when the player is shot, there is a different message than if the player has exploded, or even if the player killed himself. Then I had to create a player state to handle the death count. I increased it in the respawn function and I displayed it on the player's screen. Next, I moved on to the player kills. If a player killed someone with their projectile or with explosion, they got +1 kill for each person, and I displayed that in HUD as well. During testing, I noticed that something was wrong. When the host was close to the wall, the particles spawned. But if it was client, the particles didn't spawn. The fix for this was pretty easy, because I just had to wrap it up with the net multicast RPC. And that's all. After that, I made runtime variable in the game state, and I updated it every second in the game mode. Then I accessed it through the HUD widget and I displayed it on screen to all the players. I tested it, and with the timer everything was perfect. But there was something off with the killing, because after the player died, they could still be killed. If you spammed the left mouse button, you could kill the same dead player multiple times, and every hit counted towards the kill count. I had already disabled the collisions on the capsule component, but I forgot that I also set the mesh collision profile to ragdoll, so it was colliding with this. Since the ragdoll was blocking projectile, it caused damage to the player. The fix for this was to make the projectile ignore physics body and block the pawn itself. After that, it worked exactly as intended. Then I implemented teams, blue and red. I stored the team name in the player state, so every player can have their team. I overrode the post login function in the multiplayer game mode, and in this function I assigned the players to their new team. It was a pretty basic logic. If the blue player killed the red person, it gives him the point. And if the red player kills the blue person, it gives him the point. So, pretty basic, I think. I also made a UI that shows both team scores with the timer in the middle. And in the top right corner, I added text showing if you are on the red team or a blue team. And finally, it was time to ship the game. But in a shipping mode, I couldn't just join the server like in a development. So I had to create a lobby map containing a host game and join game buttons. When the player pressed the host game button, I used server travel to load the new level. And when the player clicked join game, I used just open level function, but with my IP. In this example, just a local host. After shipping, I tested it. I opened two instances, and in one I clicked host game and in the other I clicked join game. Everything worked, except when I was moving as a client, the whole player character was jittering and it felt incredibly laggy. And why is that, you ask? Remember when I said I changed some mesh replication variable in my character? Yeah, that was the problem. I wasted another hour on going through all of the networking variables in the blueprint character because I didn't realize it was just because of this one minimal change. When I finally tracked it down and fixed this, the jittering was gone. I stopped the recording there, I tested this game some more, and after that change, everything worked perfectly. The movement wasn't laggy, the character wasn't jittering, and kill count, death count and all of that was working as expected. So yeah, that was all I was able to do in 7 days without knowing anything about a multiplayer and networking. If you liked my horrible journey and you want to see me struggle even more by making a better game, please like and subscribe. So thank you guys for watching and till the next time.